graphing linear equations by finding intercepts. Let's first review what a linear equation looks like in standard form. A linear equation in standard form looks like this. ax plus by equals c, where a, b, and c are real numbers. My variables are x and y. Now for this lecture, I'm going to only talk about equations that are in standard form such that a and b are not equal to 0. Okay? So each example, our a and b will both be numbers other than 0. Let's take a look at an example of a linear equation. I'll just make one up. How about 2x plus 3y equals 6. Notice this equation is a linear equation. It's in standard form. My a is 2, my b is 3, and my c is 6. What we want to do is we want to graph this equation. Now, to graph a line, now we know this is a line because it's linear. Linear has the word line in it. Whenever we see a linear equation, it means we're going to graph a line, or that equation represents a line. Now we want to graph this line. So we want to graph the line. You know, maybe the line looks like this, comes down, maybe it goes up, straight across, whatever. But we're going to try to find this line on this rectangular coordinate system. Now, every single line such that our a and b are not equal to 0 must have what's called an x-intercept and a y-intercept. The x-intercept is the place on the x-axis where the line crosses. There would be an example of an x-intercept. The y-intercept is simply the point on the y-axis where the line crosses. So that might be an example of a y-intercept. Now notice, to graph a line, you simply need 2 points. So if we could find the x-intercept, and if we could find the y-intercept, all we'd have to do is connect the dots. Now this is not this line, this was just an arbitrary example to illustrate what an x-intercept and a y-intercept is. But what we're going to do, we're going to take our linear equation. I'm going to attempt to find the x-intercept. We'll find the y-intercept, and we'll connect those 2 points with a line. So let's do our example. 2x plus 3y equals 6, and we'll try to find the x-intercept and the y-intercept. Okay, so let's see. Step 1. Let's find the x-intercept. Now the x-intercept must be somewhere on the x-axis. Now, what is the y-coordinate of any point on the x-axis? In other words, how high up are we? Well, we're up 0. Any point on the x-axis has a y-coordinate of 0. So to find the x-intercept, we simply set the y-coordinate equal to 0, and we solve for x. So let's set y equal to 0, which means wherever I see a y, I'll plug in a 0. So I get 2x plus 3 times 0 equals 6. 2x equals 6, divide by 2, x equals 3. So that means the ordered pair, 3, because that's the x value, comma 0, is my x-intercept. So I'll go ahead and plot that. Over 3, up 0. And there's the x-intercept. Now we'll find the y-intercept. Now, the y-intercept is somewhere on the y-axis. So we have to ask ourselves, what is the x-coordinate of any point on the y-axis? Well, just like the x-intercept, the y was 0, on the y-intercept, the x-coordinate is 0. So to find the y-intercept, we simply set x equal to 0, and we'll find the corresponding y-coordinate. So wherever I see an x in my equation, I'll plug in a 0. So 2 times 0 plus 3y equals 6. And we'll solve for y. 2 times 0 is 0. So I get 3y equals 6. Divide by 3. Y is equal to 2. So what's the corresponding ordered pair? Well, the x-coordinate is 0. The y-coordinate is 2. So there is another ordered pair. That's the y-intercept. So I'll plot that point. Over 0, up 2. Now notice I have now found 2 points. That's all it takes to sketch the graph of a line. I would encourage you to now draw this with a ruler. I'll attempt to do it freehand. We'll just simply connect the 2 points with a line, and there is the graph of 2x plus 3y equal to 6.